Okay, this question was a fun one about discrete random variables. The example seemed to come up with more and more imaginative ways of putting this into questions. So to start with, we've got our fair, that's going to be important, six-sided black die, has got faces and they're numbered like this, and random variable b is the score when it's rolled, and we want, it says write down the value of E of B, so the expected value of B. Well, so let's have a look at this. As you can see, this is symmetrical, which means the mean or the expected value will be in the middle, so that's 2.5. So that's why it just says write down. You could work it out as all the probabilities are a sixth, but write down means it should be quite easy to do. Or you could put that in your calculator if you're stuck. Right, now we've got a white die, which has this probability distribution, and Greg and Nelia are going to play a game. Greg rolls black dice, Nelia rolls the white die. Greg is going to win if he scores at least 2 more. And they're giving us the probability of winning, and we're going to find the value of A and B. Now, this isn't the quickest way to work this out in the exam, but I'll just show you something that can help you think about this if you're not sure what's going on. So what possibilities have we got? Well, Greg is playing with the black die, so this is Greg. The black has values 1, 2, 2, 3, 3, 4. And then Nilaya is playing with the white die, and that has values 1, 2, 4, 5, and C is greater than 5. Okay, and then I want to know, when does Greg win? He's got to score at least 2 more. So if Nilaya gets a 5 or above, Greg can't beat that. So all this section's gone. Greg is going to lose. If she gets a 4, Greg can only even that, get equal. So Greg is still going to lose. Right, if Nilaya gets a 2, Greg can get 2 more than that when he gets a 4, but all other places he loses. If the white die is a 1, Greg can beat that by 2 or more by getting a 3 or a 4, so he wins in these situations. So now I can see all the possibilities for Greg winning. So in order for Greg to win, right, you can see this is, he has to have, that's the probability, the black die is a 3 and the white die is a 1, and these are being rolled independently of each other, so we can multiply the probabilities together, get the probability of black 3 and white 1. Or black can get 4 and white can get 1, so again we can multiply those probabilities together. Or black gets a 4 and white gets a 2. So because these are mutually exclusive events, there's no overlap, then when I'm saying or, I can add the probabilities, and because they're independent, when I'm saying and, I can multiply the probabilities. So the probability of Greg winning is 1/6. So the probability that black is 3, well, all these are equally likely, so they each have a probability of a 6th. So they're 2 3s, so that's a 6th plus a 6th, so that has a probability of a third. The probability of white getting 1 is A plus B, plus the probability black gets 4, there's only one of those, so it has a probability of a 6th, times the probability of white getting 1, which was A plus B, plus the probability black is 4, we know that's a 6th. Look at the table, white getting 2, that's A. So we've got an equation here, and then you can simplify that and get 1/6 is 2/3 A plus a half B. And then you might notice we have a problem because I've got 2 unknowns on one equation, so I need to think of another equation. Well, remember the sum of all probabilities should be 1. So the sum of the probabilities W equals W must equal 1. So that means A plus B plus A plus 0.3 plus A plus B must equal 1. And I can simplify that as well, so that can give me the equation that 0.7 is 3A plus 2B. So I've got one equation, I've got two equations. I solve those simultaneously, either by hand or in your calculator, making sure you put the values in the right order. And I get A is 0.1, B is 0.2. And you might find it helpful at this stage to then go over your table and write in what these values would therefore be. Okay, so then they bring in linear coding, so another topic. So they've got the random variable x is 2w minus 5. And this might look a bit out of context, but w is the same w that we've been using all question. So it's this. That's our w. We're given the mean and we've got to find the variance of x. Okay, well the first thing is we know with linear coding that if the expected value of x is 2.6, then I can just replace x and w in my formula, because linear coding, the mean is affected by both the multiplication and the subtraction here. So the mean of x is 2.6, and that's 2 times the expected value of w minus 5, and I can get that the expected value of w is 3.8. Then I have to think, well, what can I do with that information? Well, I didn't know the value of c, so maybe this can help me. So remember that the mean of w is going to be the sum of all the values times their probabilities. So that's going to tell me that 3.8 is going to be equal to 1 times 0.3, so that's its probability, plus 2 times 0.1, plus 4 times 0.3, plus 5 times 0.1, plus c times 0.2. And if you then solve that, you can get that c is 8. So now I know c is 8. I've got a complete distribution. Once I've got that, what do we need? We want to find the variance of x. Well, we could use linear coding to help us solve this, because we now know the mean of w, so we could get the variance of w. And the formula for variance is the expected value of w squared minus the mean, or the expected value of w all squared. So we can then get the mean of w squared using our new values, because now we've got all those in the table. So that's every value for w squared times its probability. So now I've got that is 20.8, so my variance of w is 20.8 take away 3.8 squared, which gives me 6.36. What do I actually want? I wanted the variance of x. Now, variance is only affected by multipliers, so you can see we've got a 2 there. And remember, variance is standard deviation squared, and so also when we scale, we square the number that we're multiplying by there. So that's 2 squared times the variance of w, which is 4 times 6.36, which is 25.44.